Hello, my name is Michael Worthington. I'm a dendrochronologist. I use a technique called tree ring dating to date the timbers from historic structures. I'm just going to do a brief description of how dendrochronology works. As you can see from this picture, when we were all children, we were taught that if you count the annual rings inside a tree, you could tell how old a tree was. The thing they didn't tell you was the widths of those tree rings are not the same. The width of those tree rings are dependent on a limiting factor to growth, i.e. something that stopped them growing. And what it is with trees is that limiting factor is climate. So if you get a warm, wet year, you'll get a very wide ring. And if you get a drought year or a very, very wet, dark year, you'll get a narrow ring. And over a long period of time, that will be unique. And all trees growing in that climate will pick up a similar pattern to that. The way we start dendrochronology is from living trees because we know they're standing, we know they're living. If we take a core out of them, because we know the date that we took the sample, we can assign a date to the outside ring. So if we think of the blue line as the data that we got out of the tree that we just sampled, and the red line is from the felled tree that we found in the woodland. We've measured the rings very accurately under a microscope. We plotted graphs, very simple logarithmic graphs, and we compared them very simply. And you can see that these two graphs and these two trees are not the same, but they're very close. You can clearly see how well they're matching together. So trees in the same climate region will pick up a similar signal like these two have. Now, as we know the date of the tree that we sampled, we can assign a date. So the tree is 2020, we just sampled it today. And because we've matched the other tree against it, we can now assign a date to those rings as well. So as we can see here, our red tree is sometime, I don't know, just before 2008, somewhere around there. So we basically dated that felled tree that was in the woodland. And what we've also managed to do is we've managed to extend the chronology back. And by doing more and more trees, buildings, we can get longer and longer chronologies, denser and denser chronologies, more replicated chronologies, which means we can date more things. So this is just an example of a chronology that we were making up in Boston, in New England. And we went from living trees to structures to actual archaeological material. So trees are basically very large plants, so they're affected by climate across the whole country. So what that means is we cannot get, I don't know, data from New England and try to match trees growing in, say, Arizona, because it's just not going to work. The climate system for those two areas of the country are so different. So you basically have to do things in a very local manner, within a couple of 100 miles at the very most. So I'm going to use Virginia as an example rather than Maryland. You can see it clearer here. So in our area, we basically have three climate zones. We have the Shenandoah Mountains in dark green, you've got the plain area in the light green, and then you've got the Bay Area in the yellow. And this affects trees very differently. So the trees that we collect from up in the Shenandoah, up in the mountains in the Shenandoah Valley and over there, up there, you get trees which are on the edge of their range, and they tend to be slightly more stressed, and they tend to pick up the climate signal really clearly. And they will match hundreds of miles. They'll match other sets of data hundreds of miles. But when you come down to the Bay Area and you get towards the shore there, the trees are actually very lazy, not very stressed at all. And the chronologies you get from there tend to match much smaller areas. And I tend to have quite a lot of problems when I'm working right on the bay. Some areas match really well, but some areas are really awful. These are the main timbers that we use in dendrochronology. So we've got the oaks, red and white, tulip poplar, pines. We have white pines in the north, yellow pines from the south, and we get a little bit of eastern hemlock, particularly in Pennsylvania. Another wood we get quite a lot of is American chestnut. Unfortunately, we can't date that because its limiting factor isn't climate. So the question has to be, what has dendrochronology and all this stuff got to do with historic buildings? Well, the thing about historic buildings is you've got to remember is there are no power tools. So everything is done by hand. So if you dry that wood, season the wood, it becomes much harder to work with hand tools. So a job that might take a day will suddenly take a week. So carpenters in the past knew this, and what they would do is as soon as they cut a tree down, they would start shaping it into what the final form would be. So this is a list of the things I'm looking for when I arrive at the house. I'm looking for 6 to 10 good samples from the primary phase of the building. I'm looking for samples which have got more than the 50 annual rings, preferably bark or bark edge on as many of those samples as possible. I have to check that timbers aren't reused or repairs. And I also have to understand the architecture development of the building, i.e. what's the history of the building, how is it built, are there additions, are there repairs or whatever. So before I start drilling any holes, I've got to try and work out how the wood was converted from the tree. So we're looking to see the most optimal position for drilling the core so we get that bark edge and we get as many rings as possible. So this would be a good sample. It's from a small house in Shropshire. It's a post, which is basically a tree that's been quartered. Got lots of rings in it and bark edge. This is a picture of a big timber frame building in North Wales, and you can clearly see that when the carpenters repaired this, because it was a museum and they wanted to show the repairs, you can clearly see what's been repaired. And if you sample any of that sort of lighter wood, you'll get a different date to what the original building should date to. So when we're working in the building, we make a record of exactly where we take samples from, and every sample has a unique number. So if we do find a sample that comes up with a different date than the main group, we can go back into the building and see what we've missed. So as you can probably tell from my accent, I'm not from this country, I'm from England. And I was trained by English Heritage to be a dendrochronologist. And when I worked in England, I got to do some pretty amazing buildings. I got to work in the Tower of London, which although it looks like it's one build, is actually about 20 different phases of structure. I worked in places like Windsor Castle, which has amazing survival, like a 14th century cloister inside there. And I worked on places like Chepstow Castle. At Chepstow Castle, we worked on not only the standing structure, we also worked on some of the fittings and fixtures. This is a pretty big fixture and fixture. Pretty big fitting and fixture. It's the main door going into the outer moat of the castle, and we managed to date this and shown that the one that they had on display in the building was actually the original door to the castle, and dating this door totally changed how the development of the building was understood. I also worked on cathedrals, very big buildings, huge amount of wood in them, and every single roof line you can see is a different date, because these things took 50, 100, 200 years to build. So when we're working on these, we're trying to work out the development of how that cathedral got there. There's an interesting thing. When we were actually working at Salisbury Cathedral, we did some work on the Bishop's Palace, which is a building that sits right next to the cathedral. It's now used as a school. And on the wall there's a picture of the architect who designed a part of the building with a picture of his drawings and a date on it. And if you look closer, you can see the date up here. And when we did the dendrochronology, we came out with exactly the same date. So sometimes it's nice to get a bit of reassurance that we're doing the right thing. The other interesting thing we found out was when they were building cathedrals, they were basically using a huge amount of wood. They used so much that they actually ran out, the cathedral actually ran out of oak suitable enough to build a cathedral. So what they did was they went to their sister cathedral in New Ross in Ireland and got wood from there and imported it in to finish the cathedral. And the dendrochronology showed this really clearly, because as you can see by the dots on the screen, the bigger the dot, the better the match, the better the t-value. Statistically, how well things match together. So you can see the big dots are in Ireland, so that's where the wood came from. When I was actually training, I went to Sheffield University, which at the time was the English Heritage Lab, and I was the new kid on the block, and basically they just gave me a box. Here, Mick, just go and do this. Go in the corner and play with this box of wood. And it was a box of wood that's been taken something like 25 years earlier from a small church in central England, and they were given to me, and I sanded them all up and I started measuring them, and I suddenly managed to get a date. And the date is really significant because it makes it the oldest complete standing building in Britain. And so a report that was going to just have my name on ended up with about 6 people's names on. When I was in England, this was actually where my laboratory was. And it's also a very traditional crook frame building, that the kind of building that we probably did 200 or 300 of them when I worked in England. This picture here, this ski slope, was a really big helper when I got here. And what happened was, when they were building this ski slope, they actually managed to get dendrochronologists to take sample of the trees. And what they found out was these trees were actually old growth oak trees, which they got a near 500-year chronology. So in one go, we managed to get the chronology that would help us date buildings in New England. And that allowed us to do these really great salt box houses that are famous in New England. Design comes from the east side of England. Very, very usable buildings. If somebody's actually built a house, I find these really fascinating because you can build them the whole thing, or you can build them in parts. You can build a chimney stack on one room to the side, and then when you get more money, you can build the other side of the building. It makes them really sort of usable if you're moving into an area, you haven't got much money, and as you start getting money, you can expand your house. Great idea. When I was working in New England, I managed to have the opportunity to work on the Fairbanks House, which is known as the oldest colonial house in America, English colonial house in America. Well, we got a date of a couple of dates, really. It's a little bit confusing for people. We got a date of winter 1637-8 and winter 1640-41. And basically what this means is the carpenters took 2 or 3 years to cut the wood down. So they had to stockpile the wood before they could build the building. And a lot of people get confused with this, thinking the earlier date is the date of the building, where in actual fact it's the later date, because obviously the building can't go up until those later pieces of wood are felled. But telling that to the owners sometimes can be difficult. Although I've come from places where I can do castles and cathedrals, I have had the opportunity to date a number of presidents' houses. So here are 2 in Massachusetts, John Adams and the John Quincy Adams house. Moving down the East Coast down to New Jersey, I've been doing a project for the last 4 or 5 years where we've been looking at barns. It's really quite unusual to do barns because barns, there's no money in barns, so it's rare to find people who'll spend money through dendrochronology on them. But we've been really lucky to get a local historical society and a local government who are really keen on saving their historic barns. So we've done about 14 of them so far, produced a really good, strong chronology for that area. And we've been doing research looking at when the different types, when they're German influenced barns, when the English influenced barns come in, and we're getting some really useful information. Here's another president's house. This is a really cool one because when we came to this, there's a story that Washington's father had built a house which was knocked down, and then George Washington built Mount Vernon, where in actual fact when we got there, you could clearly see a set of bottom plates underneath the building in the attic, in the roof of the attic, that didn't fit the building as it stands. And we dated that, and we got it to a date of 1732, which is obviously much earlier than Washington. So we managed to find Washington's father's house. So without dendrochronology, the way that we date historic structures is with the help of an architect historian. Architect historians who have been in one area and have managed to study hundreds and hundreds of buildings can come into your building and look at it, and just from the floor plans, materials, the nails and the style of construction can give a date range. If you spend a lot of time like Orlando had in Maryland, you can get very good. And this is one of the best ones I think I've ever seen. He actually got the date absolutely spot on. Pretty amazing. So a question I'm asked quite a lot is how has dendrochronology changed the study of architectural buildings, architectural history? Well, you can clearly see from this graph that when dendrochronology comes in, there seems to be a little bit of a realignment of some of the dates. So this is from New England. When we arrived up there, when we'd done about 40 or 50 buildings, we managed to go back and look at all the ones that had historic structures report where it had been studied basically by an architecture historian. And this graph basically shows you the difference between what the dendro dates were and what the estimated dates from the architecture historians were. And you can clearly see there's some discrepancy. And if you put that into a simpler graph, you can see the dendro dates which are later is more than half. Dendro dates which are the same was a little bit below a quarter, and then we make a quarter earlier. So one of the main reasons I find that people make mistakes dating buildings is they take the documents too seriously. It's very hard to tie a document to a building, to a structure. It's much easier to tie it to the piece of land it's on. So a good place to investigate this with Baltimore, where we actually have all the records. They all survive for not only the property transfers, tax records, probate records, all survive. So you can basically go in there and date your building online. You can do it in 20 minutes online. It's pretty amazing. Just use the lot code from your tax bill and you can do it. So here's an example from there. And if you were just to do that without knowing about dendrochronology, you could easily fall into the trap where you think this building is from 1799. That is if you were not that good, because if you closely looked at this building, yes, it's a federal building, yes, it could have been standing in 1799, but when you start looking at the fixtures and fittings, you would see that it was later. But with dendrochronology, we come in and we get a date of summer 1831, which clearly shows this document doesn't relate to this building. There must have been something there earlier. This is another fun building. This is a building in Virginia where we came in to date it. It's got two halves of the building. You can clearly see the big brick part of the building, and next to it and behind the tree there's an earlier frame building. And when we came to the dendrochronology, the idea was to find out how old that earlier building was. But when we did the dendrochronology, we found out that both sides of the building are exactly the same date. And when you start looking at the fixtures and fittings and things, you realize that that date's correct. And what's probably happened is this building burnt down and the owners rebuilt exactly what they had before. And people say that's crazy until you listen to people, you hear about people like my father-in-law who's had his house burned down twice and twice rebuilt it exactly as it was before. So this is a building called Cloverfield, which Willie Graham is going to be talking about. So I'm not going to go into great detail. For me, the most important thing about this building was the date, really, was the fact that we found this really early building from the 1705. Makes it a great old building which survived. So this is another great Maryland building. It's called Drayton Manor. Not only is it the main building survived, but lots and lots of outbuildings survived. So along with Maryland Historic Trust, we went in there as a part of a easement project where we basically went in and got the opportunity to study the buildings. And the dendrochronology basically gave us a range of dates for the primary part of the building from the 1730s all the way through to the hyphens going in the 1800s. We also managed to move the owner, which owner owned the house during the different times that the buildings were built. But for me, I think this particular property, the best part about it was not the main house, although the main house is pretty phenomenal. It's the survival of all its outbuildings. You know, how often do you see laundries and bathhouses surviving? So that makes Drayton Manor a pretty unique place. This is another Maryland building. This is the old Y Mill. The question here was obviously how old the mill was, but the thing about mill buildings is they're machines. So they get changed whenever a new technology comes in which can grind flour quicker or is more hygienic, or they change from flour to grist or whatever else it might be. These buildings are constantly changing, and when they do that, quite often the outside frame of the building gets changed. The other thing is they're on rivers, so they're susceptible to floods. So if you get a big flood coming down there, it's very common to lose the mill. So with these buildings, when we're dating them, there might be documents pushing them back all the way to 1600 like this one. We're basically looking at what we can see is is original standing structure. And when we dated this one, we got these dates, which are pretty early, pretty amazingly early, but not quite as early as some of the people who work at the mill thought it might be. So this is an interesting building. It's a log cabin, Hagerstown, Maryland. It's a building that initially was covered in siding and just looked like every other house in the street. You couldn't tell it was a historic building until one day a police cruiser came down the wrong way, down a one-way street, smashed into the side of it. The building got condemned, the people living there moved out, and it started getting vandalized, and people realized that there's actually a log cabin under the siding. This is an area of the city that is on the cusp of going down really badly or could be gentrified, and the city basically has stepped in, and a number of organizations have also stepped in trying to sort of save this area of the city and save some historic buildings. So Preservation Maryland bought the building. The Western Maryland Community Development Corporation are involved, and also the Maryland State Highways Authority are involved. They actually funded archaeology and my dendrochronology on the building. And the idea is to produce, is to renovate the building and rent it out for low-income rental, but in a pretty nice historic building. When we dated it, we got a date of in the 1740s. Unfortunately, the building itself, the area is really from the early 1800s. So there's a question about the date, but when you start looking at the building, you can clearly see there are a lot of anomalies that would suggest the logs have come from somewhere else. The whole building is built from reused timbers, and the dendrochronology seems to say it comes from Hagerstown because it matches another log house rather than cabin, a two-story log house that used to be in the city. It matches that really, really well, to the point the trees were probably growing in the same woodland, and they probably came from another log house rather than cabin, so a two-story type building, which obviously got knocked down. They got the timbers and made this building. So moving out of Maryland, going down into Virginia, this was a project I did in Alexandria. When they're doing waterfront development in Alexandria, there's a real problem because in the 1750s the town expanded, and rather expanding away from the river, actually expanded into the river. So whenever you dig to build new developments, particularly when you're putting under building garages in or parking in, you find ships. So this was a ship that's under a hotel now called the Indigo Hotel. We came in and sampled this building. And found a date of 1741. But what was interesting, because if you think about a ship, it's not where they sink isn't where they were built. So when you're doing dendrochronology with them, you don't just look at local chronologies. You throw chronology, every single chronology you have basically at it, just in case it came from somewhere else. And in this case, it did. If you look at this list here, you can clearly see that the buildings it's matching with are coming from Massachusetts, and basically matches highly with chronologies from a place called Rockport, which was a maritime town and did build ships. So the question is, did that ship get built in Rockport? The timbers from this ship were actually lifted and were put in the old bus garage in Alexandria, and we've had Texas A&M come up and scan all the timbers so we can try and reconstruct the boats. And when they were doing development in the next plot over, we found another 3. So this week I've been working on the other 3 ships from Alexandria. So this is another building from Virginia. It's for the Park Service. When you look at it like this, it looks like it's a big building with a little shed on the back. But when you start going inside it and looking at it, you soon realize a large section of this building is very late. Got lots of modern stuff in it. So here's a fancy scan looking into the building. You can see I've got a date of 1824 for the building, but what that actually dates is the timbers under that floor, the timbers under that floor, and some reused timbers up here. So basically what we've got is we initially had a building, 2 rooms either side of a chimney stack, and then the front of that's knocked down when they put in this newer front addition. This building is in the process of getting renovated and will be part of the park tour in the future. So going a little bit further down into Virginia, these are some buildings from Colonial Williamsburg. Colonial Williamsburg has this really interesting map from 1782 called the Frenchman's Map. I think it's a spy map where somebody came in and basically drew all the buildings in the town. And what the art historians at Colonial Williamsburg have been doing is basically every time one of those buildings come available that's marked on the map, they go in and record it. So as a part of that recording, Jack Heikkinen would come in as a dendrochronologist, and then I came in subsequently, and we would basically date the buildings, which would give them a dative framework for them to study their buildings. Some of the interesting things we found, the Robert Carter house there, we actually pushed that back a generation. So rather than Robert Carter, it was actually Robert Carter's father who actually built it, who was actually also called Robert Carter. So it means they didn't have to change the name, which is always good. So now moving down to North Carolina, this is a house, tiny little house on a back street in Edenton. If you drove down it, you wouldn't even notice it. It was bought for, they turned to a rental property, and the builders working on it realized the timber in it looked a lot older than the normal 2x4s they deal with in these houses. And a lot of people got very excited, and I got called in to come and do dendrochronology as a part of that. And I managed to get a date of winter 17, 18, 19. And it turns out this is the oldest building in North Carolina. Really cool. Going down into South Carolina, this is Drayton Hall, just outside Charleston. I was actually at a lecture. I was listening to a lecture, and somebody told the people in charge of this building that there was a dendrochronologist in the building, and they basically banned me from leaving the city until I'd come and done sampling at their property. So we went in there and we dated it to 1747-48. And before that, the dating was actually on a letter from 1743 where somebody had said they were going to see a new child at Drayton. And that's how they'd been dating the building. So when I came in and did the chronology, we changed the date of it slightly. But it means now we have a much better picture of the history of this building. Another project I've been working on for the last 5 or 6 years, it's actually looking at vernacular buildings in Georgia. In Georgia, there's very, very little dendrochronology. Before I started this, there was probably only 2 buildings done in the state. And so when I got there was very little data. So we basically managed to get a big lump of money together, and we did a lot of buildings, not purely because of their architectural importance, but because of the amount of wood they contain to produce chronologies. And we initially did 10 buildings, and on the back of that we produced a couple of really good chronologies, and subsequently we've done another 4 or 5 buildings. So this has made that now that we can actually date buildings in Georgia, an area of dendrochronology I find really interesting because it's much more of a challenge if you've got no data, because trying to get things to date is so much harder. So finally, I'll do a breakdown of the buildings that I've done down the east coast of the USA. In New England, Massachusetts, Connecticut, and New Hampshire, I've done 45 sites, 70 phases of building. In the Mid-Atlantic, I've done 168 sites, a total of 277 phases of building. And finally, the southern states, North Carolina, South Carolina, and Georgia, I've done 24 sites, 61 phases of building. This is slightly out of date. I've done a few more in Georgia since then. If you're interested in looking at some of this information, if you go to my webpage at dendrochronology.com, you can see a map of all the buildings I've done, and you can see a description of all the buildings I've worked on. Thank you.